I'm Wisdom Matthew, a backend engineer at Nala, and I'd be talking to us on distributed mutex and Go with Redlock. So let's get started. In a distributed environment, one of the problems you might run into is a race condition where you have like multiple processes trying to modify the same resource at the same time, basically. And what you might get as a result of that is data corruption, where one of them overrides the other or steps on the other one. And yeah, there are different forms of, there are different ways you might end up like in a race condition where there are different scenarios. But for this very example, I have here on the slide, we have like two processes just basically taking a JSON file from S3 bucket, extending it, then writing back to S3. So in this case, they're both running concurrently on the same config.json file on S3. And what we end up with is if they both happen to run at the same time, we might get a scenario where one of them like steps on each other, overriding the other one. So normally this is what we want, where, so just for a bit of more context, process B just adds a B key value pair, and C does something similar. And in the end result, we want something like this, considering that we're not like overriding the whole JSON config, right? But then, if we have a race condition, we might end up with this or this, right? Depending on which of them writes last to S3, which is, I mean, this is usually like very painful to debug on prod, right? Because you can't simulate network cores or the exact state of your CPU and all that stuff. So, so basically, this is like a scenario where we might want to use like a distributed lock. But before we go into like the details of that, I'll be walking us through what a distributed lock is, just to ensure everyone here gets carried along for folks who might be hearing about it for the first time, or maybe not. And just giving us specifics on building distributed locking in with Redis, basically. So yeah, what's a distributed lock? So basically, a distributed lock coordinates access to shared resources in like a distributed environment, ensuring that only one of them can access or modify the distributed the resource at the same time, right? So distributed locks do come in different forms. You can have like a read-write lock where you want to protect both read and write, but most times people use locking for mainly protecting writes, since we do have some consequences with that. But same concept does the same thing, right? So why do you need a distributed lock? The first example I've given before is to prevent race conditions, right? And you might also use this to protect shared resources and avoid double processing with duplicate side effects. Let's say we have a cron job that runs every 5 minutes, for instance. And basically what it does is that it takes like backlog emails and sends to users. If you have, for whatever reason, one of the jobs delay beyond 5 minutes and you have another one kicking in, you might end up sending emails twice to the same set of users, and yeah, that's not great. So basically we can use like a lock to like lock that particular operation. So resource, like I mentioned earlier, isn't always like say a record in your database or something on Stripe or S3. It can also be like a process. Any resource you basically want to protect is like falls under that category, right? So one of the use cases for in-memory storage systems like Redis is for implementing a distributed lock manager. And as a result of that, there was like a draft on how to build like a distributed lock with Redis, basically. So at its core, Redlock is just an algorithm for building like a distributed lock manager on top of Redis, right? So it's not like a plugin, it's not an extension you install, it's just an algorithm. So as an algorithm, it means that there are like different implementations of Redlock in different languages. There's one in Python, C#, Ruby, and the likes. We also have like an implementation in Go, which I'll be showing us a quick example towards the end. And yeah, Redlock does provide some guarantees, right? So one of them is mutual exclusion, which is Mutex, basically in the title of the talk. So what this means is that at any point in time, only one process can access a resource or modify a resource. At any point in time, only one process can acquire a lock on a particular resource. That's what I meant. Then you also have deadlock free as well. So eventually, all locks end up released because if let's say a client acquires a lock and it crashes before releasing the lock, it expires because we configure like an auto release time. And fault tolerance, as long as we have like majority of nodes up, we'll be able to acquire and release locks as usual. And so basically this is a quick diagram I drafted of the Redlock algorithm. So in hindsight, it might not be like extremely detailed as the official docs, but I would explain them basically. So just for a bit of context, Redlock works mainly on Redis masters, right? So you can have a replica-based setup, as that would simply break the algorithm, where you write to like the master and the data gets replicated over to the replicas. So in this case, we assume like we have 5 Redis masters. We can probably have 3 as well, because Redlock works with a majority-based selection process, where if we're able to like win the lock-in on majority of the nodes, we consider it acquired. So in the first step here, as you can see, we capture like the current time in milliseconds. This would be used for computing the time that has elapsed. Then the distributed lock manager goes through each of the nodes trying to acquire the lock. In the comment slide, I will explain like the details on how this works on a single instance. But basically, after all of that is done, we try to we compare if the time elapsed. We calculate the time elapsed, then compare if it's still within our validity lock validity time window, and if it is, and we're able to capture like a majority of the locks, basically we go. In this case, we have 5. If we're able to acquire the lock on like majority of them, let's say at least 3, and we're within the validity window, we consider like the lock to be acquired, right? So this doesn't mean we just stop at 3, right? We can try to acquire on all of them, but there might be like cases where we have competing resources trying to acquire the same lock, and what you end up with is the first one that gets like the majority basically just wins the quorum. Then in the case where the checks there are not true, either we've like gone past the lock validity time or we fail to acquire a majority of the locks, we consider the lock acquisition to fail. So another thing here is there's a timeout at the point of acquiring like this lock on each instance, so we don't spend like a lot of time trying to communicate with the dead node, basically. So what happens in case of a failure? Usually with different systems, failures can occur. So what usually happens is that we first clear like partial locks, where we go like each of the attempts, deleting the basically releasing the lock. I would also explain in detail what we mean by releasing a lock with Redis, with Redlock. Then we also retry after a random delay. The goal of the random delay is to desynchronize multiple processes competing for the same lock. Basically, let's say, in the example I had earlier, we had 2 processes trying to acquire the same lock. But what if we had 20, what if we had 50? Then we end up in a scenario where maybe each of them gets 1 and none of them wins the quorum. So the random delay basically just desynchronizes them, ensuring that we don't spam the particular lock key. And so yeah, this is basically the Redis command for, it didn't fit into the whole thing. But basically this is the Redis command for single instance lock acquisition. We set like the lock key to a random value. Then the NS option basically just sets the key only if it doesn't exist. Then we provide like the lock validity time, also called like the auto release time in milliseconds. So basically, as I've mentioned earlier, what this does is that if the process for whatever reason fails to release the lock on time, it releases automatically. And the random value there is used for ensuring that we release the lock in a safe way. So we don't like have cases where you have 2 processes trying to acquire the same lock. Then in the process of cleaning up failed attempts, you release the lock acquired by a previous process. And this is the command for releasing a lock on a single instance, right? So basically this is a Lua script, and it runs atomically on Redis, ensuring that in the process of doing all of this, we don't run into another race condition. So yeah, basically what this does is that we first get the key, then compare if the value we get for the key in Redis matches the value we provided at the point of acquiring the lock. If it's not the same, we just skip, we do nothing, right? If it's the same, we delete the key, and that's it. So let's go back to our example that I brought up previously, right? So if we were to introduce a distributed lock, what would that change? In this case, as you can see now, before starting any process on the config.json file on S3, we first acquired the lock, right? Acquired the lock using probably the resource name as the key, in this case, file config.json. And then we go ahead, we retrieve the config.json from S3, and we make the changes we want. We write back to S3, then when we're done, we release the lock. So any process that is trying to alter the same file has to first try to acquire the lock. If you have two processes trying to alter the same resource on S3, one of them has to wait for the other one. So regardless of how many we have, even though we have 10, there's like no guarantee that they would each run in the order they arrived, first thing, first come. But basically, it's just what we're aiming for here is to ensure that we don't have two processes writing to the same resource at the same time. The down part of the slide was trimmed, but I guess you guys get my point. So yeah, so in this case, what we always get is this, unless maybe one process tries to override the whole config.json on S3, which is a different problem entirely, and which is outside the scope of this talk. But there are different ways you can go about this. You can probably use like save a version in the config, ensuring that before you save. But yeah, we can probably talk more about that one. If you have that problem, we can catch up afterwards. But in the scope of this talk. And yeah, this is a code snippet from RedSync. So RedSync is an implementation of the Redlock algorithm in Go. So basically, if you're thinking of using Redis for distributed locking, you might as well use RedSync. And so this is like the code we have. In this case, we're initiating like the RedSync instance, providing the number of nodes. I used 3 just for simplicity, and also had to trim down the code so it fits into the slide. And that's it. In the next slide, this is where we're using like the RedSync instance for our lock acquisition and release. So again, I had to trim this down so it fits the slide. But basically, before we start any operation on the file, we first we create a mutex using the config.json as the key. And in this case, we have like a 30 seconds expiry duration. There are also other options in RedSync you can explore as well. Maybe configure like a delay time and all of that stuff. But if you want to find out more, you can always play around with the code, like going into details on GitHub. Then before we start anything, we acquire a lock, and we have like a defer there that releases the lock whenever like the operation is done. So this way we ensure that if there are like multiple processes trying to do the same thing, they have to wait for one of them to release the resource before proceeding. And yeah, these are basically some resources I used for putting this talk together. The first one is the link to the official algorithm notification draft on Redis. So basically, if you go there, you can read up more about Redlock. And this is the GitHub. This is the link to the GitHub repository for RedSync. And yeah, it's used by a lot of projects. And I also played around with it, used it in a side project I'm working on as well, and it was fairly well. Then these are some other useful articles I found when researching on this as well. So, and that's it. So the barcode here, basically, it's if it's scanned this, it takes you to the slide, and yeah, you can find out more. And that's it. Thank you. Questions as well.